Hello everyone. Hello. Good morning. Good morning Aditya. Good morning Aditya. Good morning Maruti. Good morning Srinivas. Good morning Arshita. Okay. So let's start. In the last class we are studying center of mass and we have done many of the things. We have seen center of mass of each and every object. Okay. How to find out the center of mass for the symmetrical, non-symmetrical, distributed, point mass. All these things we have covered. Now let's move forward today. Okay, we will do today some questions of conservation of momentum. Okay, so I will tell you some more thing in conservation of momentum. Like you have already studied that F net, when F net is 0, then only you are able to conserve the momentum. But I'm going to tell you one more thing. If the force, that is external force that is applied on any object, if, hello Aditya, if that is the external force that is applied on the object, if that is not impulsive. So what do you mean by impulsive? I will tell you. If it is not impulsive, then also you can conserve the momentum. Okay, so let's see all that things. Let's start. Okay, see one small points. Let us cover some small points. Okay, so here everyone, if I will say, if there is any object, okay, any body is there, it is rotating also, it is translating motion also. So center of mass is this, center of mass, acceleration of center of mass, and this is any point A and this is any point B. Okay, then what I'm saying, no, don't take A and B, just take anything as well. This one is A, this one is point something P, and this one is Q, and acceleration of this is A1, acceleration of this is A2. Okay, it can be in any direction. I've made it horizontal, but it can be in any direction, any damn direction. Okay, now it will depend on the rotation, how it is rotating. Okay, so on based on that it will have a direction. Now if I am saying, just tell me the true and false. If a center of mass is 0, if a center of mass is 0, it implies that a1 is 0 and a2 is 0. True and false? Fast, come on everyone. Good morning everyone. Mahindra, Ashita, Yashashwini, good morning everyone. Just tell me true or false, everyone. I want every one of you to solve this and just tell me. If A center of mass is 0, that means that applies A1 is also 0 and A2 is also 0. Good morning, good morning. Give the answer fast. Give the answer fast, everyone. Give the answer fast. If A center of mass is 0, that implies A1 is also 0 and A2 is also 0. True or false? Come on, fast, everyone. Reply. False. Vaibhav is saying false. Yes, it is false. Why? Because if any object is rotating, pure rotation, okay, for example, a rod is rotating purely from the center of mass, from center is fixed, okay, now it is doing a pure rotation with an angular omega velocity. Now center of mass is here and the acceleration of center of mass is 0, it is not moving anywhere. But if you see the point, this is moving in this direction and it is having a centripetal acceleration inside. This point is moving in that direction, but it is having a centripetal acceleration inside. So when object is rotating also and it is translating also, and if center of mass is not accelerating, then other particle can accelerate. Are you getting my point? Due to the rotational effect. Is this clear to everyone? Okay, very good. Vaibhav has said yeah, false. Yashashwini has said false. Srinivas has said false. Very good. Clear? Is this clear to everyone? Now another, can I say the similar thing? If V center of mass is constant, if V center of mass is constant, then V1 is also constant and V2 is also constant. True or false? Come on, fast everyone. True or false? The question is true or false. False. Okay. Prashad is saying false. Yes, this one is also false. Similar, if V center of mass is not moving, for example here V center of mass is 0, it is constant and it is equal to 0, but still this point is having velocity V1, here also it is having velocity V2. So this one is statement is also false. Okay, one question depends on the last class. I'm giving you. Very good, Prasad, Maruti, Vaibhav, very good, very good. Harshita, very good. Why everyone is not replying? 20 watching right now, but everyone is not replying. Why? Just tell me. Let's move forward. I'm giving you one question. Okay, I want everyone, this question depends, the theory of these questions I've already told you in the last class, so I want every one of you to attempt this. 10 kg block is here, 50 kg man is here. Okay, this length is 20 meter. Frictionless surface, this wedge is kept on a frictionless surface. It's smooth, it is very smooth. Okay, now this man, everyone, what is happening? This man is shifted, it walking on this wedge and came to this point, but when this man came to the other point, other end of the wedge, what will happen? This wedge will go back. Obviously, if you are walking on a wedge, this wedge will go back. If there is a frictionless smooth, like very frictionless surface, in a smooth surface, if you are there, in a frictionless surface, if you are walking, okay, on a wedge, what will happen? For example, you can think it as a boat. If you are in a boat and if you are going in the front direction, boat will come back. That will happen. So similarly, the question is, what is the displacement of 10 kg block? What is the displacement of 10 kg block when man shifts to other end? Based on the last class, Rama, have you attended the before classes? Have you attended the before classes? Good morning, Rishi. Good morning. We are doing a crash course. We are not doing reading this for the first time, Rama. Just watch the previous classes also. Then you will get, you will understood everything. Yeah, everyone just tell me the answer. The 50 kg man has been shifted from this end to the other end. So what is the shift of 10 kg block? How much 10 kg block will get shifted? Rishi and everyone. Srinivas, Harshita, Vaibhav, Maruti, Jyoti, Rishi. Everyone just tell me what is the answer. This question based on the theory that we have read in the last class. In the last class we have read the theory. Based on that this question is depends on. You have to find the displacement. Hello Teja. Based on, hello Krishna. Based on the theory that we have read, we have differentiated the equation of x center of mass. X center of mass is m1 x1 plus m2 x2 upon m1 plus m2. So we have differentiated that to get the result. Everyone, good morning. Anyone attempting this question or should I tell the answer? Any one of you attempting this question or should I tell the answer? Come on, fast, tell fast. Okay, let's see. Everyone, we can't give more time than this much time is sufficient to solve this question. Now see what is happening. Just draw the diagram afterwards what it is for making. This block must have shifted by some distance. For example, x distance shifted. Now the center of mass has been moved from this point to this point by a distance x. We have to find this x only, that how much this wedge has been shifted. We have to find it out, that one. So let it be x. What we are saying, that this shift is x. Okay. Now this wedge has been shifted by x. And initially this man was here. Now this man is here. Yes or no? So how much man has shifted? Man has gone 20 meter in that direction, in that wedge, and that wedge has came x here. So this man has shifted 20 minus x on this side. The shift of this man is 20 minus x. If wedge has not moved, just remember this, if wedge is not moving and if only man is moving, then how much will be the shift of man? 20. But man has traveled that 20 meter on the wedge, but that wedge has came back, how much? X. So how much with respect to ground, how much this man has traveled? 20 minus x. Are you getting my point? Is this clear to everyone? Just tell me fast. Is this clear to everyone that how much this man has traveled? 20 minus x. This man has traveled 20 minus x. Is this clear? Man was initially at this point. Now it is at this point. So this length is 20 minus x. Now in the last class I told you, see I am again deriving that. X center of mass is m1 x1 plus m2 x2 upon m1 plus m2. Then what we have done, we have differentiated this equation. So we got the change in x center of mass is going to be equal to m1 into dx1, change in x1, plus m2 into dx2, change in x2 upon m1 plus m2. Now there is no external force in the system. Are you getting my point? If you take the man and the wedge as a system, there is no external force. And if there is no external force in the system, then net center of mass will remain at the same point. Are you getting my point? Center of mass will not change. That means x center of mass is 0. Whenever there is no external force on the system, then center of mass will remain constant. Velocity of center of mass will remain constant. Are you getting my point? And here that velocity is 0. That means it is not moving. Center of mass will be at same point. So 0 into m1 plus m2 will also become 0. So you can say m1 dx1 plus m2 dx2 is going to be equal to 0. Are you getting my point? You can remember this directly when there is no external force and center of mass is at rest. Then you can apply m1 x1 plus m2 x2 is equal to 0. m1 dx1 plus m2 dx2 is equal to 0. What is dx1? dx1 is change in x. Change in x1. What is dx2? Change in x2. Are you getting my point? dx1 is change in x1, dx2 is change in x2. Are you getting my point? So now just directly solve it here. This one is 10 kg block that has been shifted by x, mass of the man is 50 kg man that has been shifted by 20 minus x. What I told you, one more thing that you have to keep in mind, the direction. If the right direction you are taking as positive, then the opposite direction will be negative. Are you getting my point? So just see here. This man is shifting towards right direction and I am taking it positive. So m1 x1 dx1 plus m2 x2. Now x2 is minus x. Why minus x? Because it is in left direction. The right direction we have taken it as positive. So left direction will be negative. I am doing right, but here it is showing left. It is a mirror image. Okay, just remember that. Minus x is equal to 0. So 1000 minus 50x minus 10x is equal to 0. So 60x is equal to 1000. So x is equal to 100 by 6. 50 by 3 is the answer. Anyone got this answer? Anyone? Harshit, Srinivas, Rishi, Teja, Jyoti, Himasri, Prasad, Krishna, Srinivas, Vaibhav, Maruti, Kanori, Yashashwini. Anyone got this answer? Renu, hello. Anyone of you got this answer? Then just tell me, please, fast. Anyone got this answer? And every time you can apply this m1 dx1 plus m2 dx2 plus m3 dx3. If there are more than that, you can apply this. Is always going to be equal to 0 if center of mass is at rest and F external is 0. Clear? Got it. Srinivas is saying got it. समझ गया सभी को? Do you want one more question? Do you want one more question? Or let's move forward. Okay, yeah. In this question, find out the displacement of the wedge. Find out displacement of wedge. What you have to find out? Find out the displacement of wedge when block reaches the ground. When this block will reach the ground, just reaches the ground, at that time what will be the displacement of 4 kg block? Everyone, very easy, one line question, one line solution. Everyone, Find out the displacement of 4 kg block when the 4 kg wedge when the block reaches the ground. Everyone, I want every one of you to attempt this. Everyone. Simple. You have to see in the horizontal direction there is no external force. In the down direction there is mg. But in the horizontal direction there is no external force. You can conserve the momentum also. Or you can simply say that center of mass will not move at the center. So m1 dx1 plus m2 dx2 is going to be equal to 0. Very easy. I want every one of you to find the answer. It is very easy. In the same, you have to apply the same thing that we have made before. Should I tell? After this, I'm going to tell you one very important point, okay, here. That when there will be a friction, okay, and two objects are colliding, then also you can apply the conservation of momentum. You will say, sir, there is an external force friction, but then also you can apply. I will tell you how and why. Okay, so everyone, very easy question. This is very easy question. I want answer from every one of you. Very easy question this is. Similar to previous one, just find out, let the displacement of the wedge is x on the left side. Then how much block will move forward? Yashashwini has said the answer 4. Let's see. What about others? Everyone, at least 2-3 of you give the answer. Hema, Krishna, Yashashwini, Srinivas, Tinu, Harshita, Rishi, everyone. I want every one of you to give the answer. 4. Srinivas has also given the answer 4. Let's see. Let the wedge has been shifted by a distance x. Shifted by a distance. So if this wedge has been shifted by distance x, that means this distance is also x. Yes. Now what will happen? See, this block was initially here, now it will come here. So how much it has shifted? Total is 4, 4 minus x. This length will be 4 minus x. So shift by 1 kg block is 4 minus x towards the right direction. And shift of 4 kg block is towards the left. How much? X. Now you can say m1 x1 is going to be equal to m2 x2. So 4x is going to be equal to 4 minus x. So it will come here, minus x will come here, 5x is equal to 4, x is equal to 4 by 5 is the answer. 4 by 5 will be the answer. What you are saying 4? You are saying 4, that means complete wedge has been shifted. This block has not gone forward. That block has came downward directly, vertical downward. No, the wedge has shifted by only 4 by 5. Is this clear to everyone now? You have to do this only. m1 x1 is equal to m2 x2, nothing more than that. Now is this clear to everyone? Just tell me fast. Now is this clear to everyone? m1 x1 is equal to m2 x2. Just you have to do this only. Clear? Krishna is saying clear, Yashashwini is saying clear, Jyoti is saying clear. Okay. What about others? What about others? Now, next question. Based on conservation of momentum, I already told you what is in the Newton law of motion. What is momentum? Momentum is simply defined as m into v. Mass into velocity is simply defined as momentum. M mass written in kg, v velocity meter per second. So kg meter per second is the unit of momentum. Now, when we are applying the momentum conservation, when F external is 0, F external is 0. Whenever F external is 0, then you can apply P is equal to constant. P is equal to constant means total momentum initial is equal to total momentum afterwards. This is known as conservation of momentum. Why we are writing this, sir? Because we know that force is equal to dP by dt, and if dP by dt is 0, that means P is constant. So we are taking out from the definition of second law, Newton's second law of motion, that is force is directly proportional to rate of change of momentum. So from there we have taken out, if there is no external force, then dP by dt is 0. That means P is constant, momentum is constant. Okay, so based on this simple theory, I am going to give you one question. I hope that every one of you can solve this. There is a 3 kg ball 3 kg block that has been divided into 3 parts, broken, okay, or blast. You can say there is a bomb of 3 kg, it has been blast and it has been splitted into 3 parts. Okay, initially it was 1, now it has been splitted into 3 parts. It is not the symbol of Mercedes. Okay, so each equal part 1 kg, 1 kg, 1 kg. The velocity of this 1 kg is downside 10 meter per second. Velocity of this is at the angle of 37 degree from the horizontal with 5 meter per second. What will be the velocity of this part and at what angle? Simple conservation of momentum. See, there is no external force, so the momentum will get conserved. So you have to conserve the momentum in all the direction. See, one very important thing, very important. Just after it has been broken, how much time it will take? 0.0000000000001 seconds. Okay, I am saying one thing. See, downside there is gravity, there is gravitational force G. In the horizontal direction there is no external force. Everyone very carefully listen this. This is very important. In the horizontal direction there is no external force, and in horizontal direction if there is no external force, you can surely apply conservation of momentum. But I am saying that you can apply here in the vertical direction also. You will say, sir, there is external force G, but this G is not impulsive. Just see what is this. What does that mean? This collision is taking F is equal to delta P by T. Yes or no? F is equal to delta P, change in momentum upon time taken. Now delta P, what you can write? Delta P is your F into T, force into time. Now this force is not impulsive, that means it is constant. Mg value is constant, 10 Newton, 100 Newton, something, it is constant. Now that you are multiplying with the time, for a very small time, you are conserving the conservation of momentum just in interval of 0.000000001 seconds. In this much small time, you are conserving the conservation of momentum. You are applying conservation of momentum. So in this small time, what will be the F into T? Approximately equal to 0. F is something fixed, 100, 20, or you can say here, what is the F? 3 kg blocks to 30 Newton. The force applied by Dharti Mata, the force applied by the gravitation is 30 mg. That is fixed. Now 30 into 0.0000001, it is approximately equal to 0. That's why here we can apply conservation of momentum. So whenever any force is not impulsive, every constant force is not impulsive. But if I will throw something on the wall, okay, at that time that wall is applying an infinite number of force, so that force is impulsive force. Okay, whenever you are throwing a ball on the ground, then ground is applying an impulsive force. At that time you cannot apply conservation of momentum, sure. But in these cases, in case of friction, friction is limiting force, mg is limiting force. In all these cases, if there is a force and if you are looking for a very short interval, everything. If it is a non-impulsive force and the time is very small, at that time you can conserve the momentum. Is this clear to everyone or not? सभी को ये बात चमकी कि नहीं? जल्दी से बताओ एक बार. Is this clear to everyone? Everyone, come on fast. Everyone. Hema, Srinivas, Jyoti, Yashashwini, Krishna. Everyone. Srinu. Yes. Clear? So if here in this case there is an external force mg, then also we will apply conservation of momentum. Why? Because the time interval we are taking is very small. So now we have to conserve the momentum. Everyone just tell me the answer. Everyone. I want every one of you to attempt this. Everyone attempt this and tell me the answer. Okay, everyone. Just conserve the momentum in horizontal direction and conserve the momentum in vertical direction. You will get the answer. Very easy, very easy, very easy. Basic question. Please attempt, everyone. I want every one of you to attempt this. Please attempt this. Everyone. Okay, let's see. Let's see the answer. Let's divide this velocity into two parts. Take the component of this. In this direction, it is 5 cos 37. 5 cos 37. In upward direction, it is 5 sin 37. I think now you know how to do the component of a vector. It is very easy. The side that is near to angle is cos theta and the side that is away from the angle is sin theta. Okay, so here this one will be 5 into cos 37. What will be cos 37? 4 by 5. So this one will become 4, this one will become 3. So if you write the net momentum in downward direction, it is mv. Mass is 1, velocity is 10. M into v 10. Momentum in this direction it is 1 into 4, 4. Momentum in upward direction is 3. Okay. So now let the momentum velocity of this 1 kg, that we have to find it out. On vertical direction is uy and on the horizontal direction is ux. So the momentum in this direction will be ux, momentum in upward direction will be uy. Is that clear? Now you have written the momentum of all the particles. Written all the 3 particles, you have written the momentum. Now you know that net momentum is 0. Net momentum is 0, that means net upward momentum is going to be equal to net downward momentum. Net left side is going to be equal to net right direction. So 3 plus uy is going to be equal to 10. So from here uy is 7. Similarly ux is equal to 4. So the velocity of this block is 4 meter per second on the horizontal direction and 7 meter per second on the vertical direction. Is it difficult? I am asking to everyone. Was this question difficult? You have to simply balance the conservation of momentum. Is this question difficult? I am asking to each and everyone watching it right now. Is this question difficult? vertical it is coming 7 meter per second, in the horizontal it is coming 4 meter per second. I'm asking to every one of you, is this question difficult or easy? Difficult or easy? Just tell me. Everyone, just tell me, this question is difficult or easy? Everyone, I want every one of you to reply fast. Come on, fast, reply. Should I give you one good question? Should I give one good question, everyone? Or let's move to the conservation of collision. Everyone, no one is replying. What happened? Everyone, Himanshu is saying easy. Okay. Now, let's move to the other part, that is coefficient of restitution. Now see, what does this mean? Okay. Only few of you are replying. What happened? Everyone, reply fast. Only few of you are replying. Why? Let's see. Now, coefficient of restitution. What does this mean? E. This E is simply, this E is nothing but this is simply impulse of reformation upon impulse of reform. See, this we are always saying E whenever two objects are colliding. Okay, so if one object is colliding with the another object, always remember this, whenever one object is colliding with the other object. Now, for example, this is one object, this is another object. Okay, so whenever this one object is colliding with another object, at that time what is happening? You are not able to see that, but there is deformation happening on this surface and this surface, very small. And when they are going back, at that time they are reforming. So that is known as reforming and deforming. When two objects are coming near to each other, okay, so what will happen? They will little bit deform like this. They will little bit deform. Yes or no? I am not able to make a correct good diagram. Little bit, this is deform. They deform some surface. You are not able to see that. Okay, if there is a ball, okay, rubber ball, you are able to see if you just collide them, and with a camera, if you see it in the slow motion, you will be able to see that deformation. But when there is a rigid object, you will not be able to see that deformation. But every object, when they are colliding, there is some deformation. And then what is happening? This block, when again going back, they are again gaining their original shape. So this is known as reformation. Is that clear? What do you mean by deform and reform? Is that clear to everyone? I think this is very easy. What do you mean by deform and reform? So what is happening? Some material, like rubber ball is having a property to 100% gain is shape. Okay, to 100% reform. 100% reform whatever is the deformation done due to the collision, like rubber ball and all that. Okay, that Chinese ball there, that one is coming na, Chinese ball, it is having, when you are throwing it, it is just jumping very high. That ball, I think you all know which ball I am talking about, the Chinese ball. Yeah, formula is V2 minus V1 upon V1. Yeah, very good, Sai. Sukumar. Okay. Sai, very good, very good. Okay, so that we are talking about that ball. So every object, and in some object, for example, if you take that atta, what do you call it in English? Like wheat you are making now for chapatis, that, and if you throw a ball on that, it will stick on that, they will not reform, their reformation is zero. So this reformation upon deformation depends on object to object. Some object is having very high reformation, some object is having zero reformation. Are you getting my point? Whenever two objects are colliding, they are having deformation. Now the our question is how much they are reforming, how much they are getting their original shape. So that we are measuring it from the coefficient of restitution, E. Are you getting my point? And the value of this E, I is correct, given correctly. For example, this both are coming with velocity v1 and v2, and they are going with v1 dash and v2 dash. Okay, so this V you don't remember like v2 minus v1, but you remember like this E is, everyone remember, this E is velocity of separation upon velocity of approach. What is the velocity of separation? कितनी स्पीड से दूर जा रहे हैं एक दूसरे से, what is their speed, okay, of separation, relative speed of separation upon relative speed of incidence. This is known as coefficient of restitution, E. Okay, so for that Chinese ball in which 100% reformation is taking place, in that case velocity of separation will be approximately equal to velocity of approach. In that case E will be 1. Are you getting my point? Is this clear? Is this clear to everyone? And in the case when two objects came and they just stick to each other, okay, they are 100% deformed, there is no reformation in that. In that case your E will be 0. Velocity of approach will be there, but there will not be any velocity of separation. They will remain together. Okay, they will not understanding. See again what I am saying, whenever two objects will collide, see, whenever two objects will collide, their surface will deform by very small. Okay, if this is a solid object you cannot see that deformation. Okay, but you just take the rubber ball, two rubber ball came, they collided. When they will collide, they will become deformed like this. Let me make a good diagram. For example, two ball came, they collided, then the point in which they will collide, they will deform. Here it will deform. Deform means their shape will change at that point. Are you getting my point? Both of the ball will get compressed. Now what will happen? Now after that they will go back. They came, they collided, and then they will go back due to the internal forces between them. Okay, internal impulsive forces between them. Now what will happen? When this block is going this side, this block is going this side, this will regain its shape. Initially it was compressed, now it will regain its shape. So how much any object is having a capability to regain its shape? It's defined by coefficient of restitution. If coefficient of restitution is 1, that means object can 100% regain its shape. And if coefficient of E is 0, that means object cannot regain its shape. If you destroyed it, it will be destroyed. It will not gain 100%. Now is it clear? Now is it clear? Hacker? Now is it clear? Just tell me. This coefficient of restitution E is telling you that how much an object is having capability to regain its shape. Clear? Hacker? This coefficient of restitution E is telling you that how much an object is having capability to regain its shape. Yes. So this value of E always lie between 0 to 1. Value of E is always lie between 0 to 1. Clear? In the general, whenever two objects are colliding, at that time this coefficient of restitution E is between 0 to 1. 1 means 100% elastic. 1 means we are calling it as 100% elastic, like rubber ball, that Chinese ball. Okay, E is equal to 1 means 100% elastic. E is equal to 0, inelastic. We are calling it as inelastic. Okay, inelastic collision, elastic collision. Whenever this word will come, you have to remember, if in the question it is given elastic collision, 100% perfectly elastic collision, that means E is equal to 1. It will not give you E value of E is 1. It will tell you that the collision of two objects is 100% elastic. What does that mean? That means that E is equal to 1. And if it is said that the collision between two objects is perfectly inelastic, that means E is equal to 0. That means E is equal to 0. Are you getting my point? 100% inelastic means E is equal to 0, 100% elastic means E is equal to 1. And if it is not given that it is not elastic also, inelastic also, it is something in between, then it will give you the value. In the question it will give you the value. That value of E is half, value of E is 0.4 something, but it will remain in between 0 to 1. Okay, and what does this mean? I am telling you this E is velocity of separation upon velocity of approach. Are you getting my point? Velocity of separation upon velocity of approach. Yeah, for EAMCET this collision is very important. Questions are coming from collision in everywhere. EAMCET also, mains also, advanced also, in all the 3 exams. Okay, so based on this collision we will do some questions. Okay, so directly I will give you the question. Can you able to solve this? Based on this, E is velocity of separation upon velocity of approach. You have already read these chapters. We are revising these chapters. Okay, now okay, let's talk something more about head-on collision and oblique. Yeah, anyone, can you tell me what is head-on collision and what is oblique collision? Any one of you? It's clear. Okay, any one of you can tell me what is head-on collision and what is oblique collision? Any one of you can tell me what is head-on collision and oblique collision? Let's see. When two objects are coming like this, when these two objects are having velocities in the direction of the line joining their centers. What I am saying again, remember carefully, when the velocities of particle is on the line joining their centers, is on the direction of line joining their centers. For example, this circle and this object, the line joining that points, this velocity of this also v1 and velocity of this one v2, both are on this same line, on the line joining their centers, and when they will come and they will collide, this collision is known as head-on collision. Okay, in the same case, if I will tell you, if this line joining their center, if this point is having velocity in this direction 2 meter per second and this is having velocity 4 meter per second, that one is in front but it is having very less velocity, 2 meter per second, and this object is in back but it is having more velocity, so this both will come and collide. Yes or no? This block will come and it will collide with 2 kg, for example B block A will come and it will collide with block B, and again these both velocities are on the same line of line joining their centers, so this is also a head-on collision. Okay, collide and move in same direction. Which same direction? In the direction of line joining their centers or their center of mass. Okay, and in generally in your 99.99999% cases you will have a center of the sphere is as a center of mass. What is oblique collision? this one object is coming from here, this another object is coming from here, and then they are colliding. Okay, their velocities sorry, their velocities are not in the direction of line joining their centers. See, it is having somewhere, it is having somewhere. Now when they will collide, that is known as oblique collision. Simply you can say that when it is not head-on collision, then it will be a oblique collision. Is this clear to everyone? What is head-on collision and what is oblique collision? To everyone, is this clear? Everyone just tell me, is this clear? What is head-on collision and what is different direction? Yeah, very good, Abhishek, very good, Abhishek. When it is coming in the same direction and it is colliding, that is known as head-on collision. And when two objects are coming and they are having speed, velocities not in the direction of line joining their centers, then that is known as oblique collision. Or simply you can say that if it is not head-on collision, it will be a oblique collision. Clear to everyone? See, one more thing, very important, one more thing, every one of you, just see here, clear, Aditya is saying clear, okay, Abhishek clear, Nikita clear, Yashashwini clear. Okay, now see everyone, sometimes what is happening when the question has came, okay, coming, maximum time students are applying conservation of energy. No, if E is equal to half, E is equal to 0, you cannot apply conservation of energy. Some of your energy is lost in the deformation. When these two objects came, when these two objects came, collided with each other, what happened? Some of the energy is lost in the form of deforming it. In deforming it, some of the energy is lost. And if it is not able to regain its shape completely, then it will not have that same energy. So you cannot apply conservation of energy, conservation of total kinetic energy will be same. Who said? No. Yeah, but you can apply that when E is equal to 1. When E is equal to 1, kinetic energy is, otherwise it is not. Otherwise it is. Is it clear to everyone? If E is equal to 1, value of E is 1, then only you can say that kinetic energy will be conserved. Otherwise, it is not conserved. Is it clear to everyone? I think it is clear to everyone. Very small things are there. Keep in mind everything. I will give you questions also. For every theory, I have given you questions. With the questions, we have seen everything. So don't worry, I will give you the question. Don't worry about it. But before that, just grasp these small topics that I am telling you. Very small things. That you cannot conserve kinetic energy if E is anything other than 1. If E is 0, 0.9, 0.8, 0.7, 0.6, anything, 0.5, you cannot conserve kinetic energy. Yeah. But you can conserve the momentum if F external is 0. So you will get definitely in every question you will get two equations, one from conservation of momentum and one from the equation of restitution. Are you getting my point? Okay, clear? So let's move forward then. Let's move forward. One question I am giving you. A very big wall. Mass you can take it as 1 lakh kg. A bulldozer type. Okay, a big machine is like that. It is coming in this direction with 10 meter per second and there is a small mass ball of mass which is having E is equal to half and which is coming with a speed of 5 meter per second. After the collision, see what I am saying, mass is 1 kg, just take it. Although it will not be required mass right now because I am only asking you what will be the speed and coefficient of restitution is given E is equal to half. Coefficient of restitution it is given E is equal to half. Simply, just I am giving you this question to check whether you have understood this formula or not. E is velocity of separation upon velocity of approach. Based on this, I am giving you this question, okay. So what is the question I am asking you? This very heavy block is coming with 10 meter per second, and this block, is small 1 kg block, is coming with 5 meter per second. After collision, what will be the velocity of 1 kg block? After collision, what will be the velocity of 1 kg? Everyone, I want every one of you to attempt this. I want every one of you to attempt this. What will be the velocity of 1 kg block after collision? Everyone, the hint is this big block is having very infinite number of mass, so its velocity will not change. You have to take the velocity of this block as 10 meter per second initial also and 10 meter per second final also. Are you getting my point? So whatever will be the change will be on the 1 kg block. Everyone, I want every one of you to attempt this. Very easy. The hint I have given you, the hint is, what is the hint? The hint is the mass of 1 lakh kg object is not changing. It is, sorry, the velocity of this block is not changing. It is 10 meter per second initial and it is 10 meter per second afterwards. Any one of you? Any one of you who can give the answer? Okay, answer came 5 by 4. Abhishek is saying 5 by 4. 2v2. What is v2? Let's see. Let's see. Yes. So velocity of this block is not changing. Let's say that velocity of 1 kg block after collision is v. Velocity of 1 kg block after collision is v. That we have to find it out. Always take like this. Whatever you have to find it out, just take it as any variable v. Now, what is given? E is given. E is equal to half. And what is this E? E is velocity of separation upon velocity of approach. What is the velocity of separation? This 1 kg block is going with v meter per second, and this heavy block is coming with 10 meter per second. So what will be the velocity of separation? V minus 10. Are you getting my point? If both are going opposite to each other, that means this is also increasing the separation, this is also increasing the separation. So it will become V plus 10. But now what is happening? This 1 kg block is moving with V. So it is increasing the separation. But this 10 meter per second is decreasing. So V minus 10. What is the velocity of separation? Velocity of separation is V minus 10. And what is the velocity of approach? What is the velocity of approach? Velocity of approach. See, this block is coming with 10. This block is coming with 5. So velocity of approach is 10 plus 5, 15 is equal to half. So 2v minus 20 is equal to 15. So 2v is equal to 20 plus 15, 35. V is equal to 35 by 2 is the answer. 35 by 2 is the answer. I have done anything wrong? No. Velocity of separation is V minus 10 upon velocity of approach. Velocity of approach is 5 plus 10, 15 is equal to 1 by 2. So 2v minus 20 is equal to 15 and 20 gone that side, 35. 35 by 2 is the answer. Now is it clear to everyone? Now is it clear to everyone? Now there are many questions that can be made on this collision, collision, collision and collision. See everyone, now n number of questions can be made. 35 by 2, yeah, correct answer Srinivas. Correct, 35 by 2. Everyone got this? I want every one of you to attempt this again. I want every one of you to attempt this question again after this class. After this class, I want every one of you to attempt this question again, okay? Now, I am giving you more questions based on this same theory. Based on this same theory, I am going to give you more questions. See, another question. Coefficient of restitution for this surface is half. E is equal to half. And a block is coming at an angle of 10 meter per second. With a velocity 10 meter per second at an angle of 37 degree. After the collision, what is the question? See everyone, this is the block. After the collision, the velocity vector will make how much angle with the horizontal? After collision, this block will go in some direction. So what will be the angle with the horizontal? E is equal to half. Initial velocity is given. Neglect gravity. Neglect gravity. Neglect gravity. Everyone, I want every one of you to attempt this question. Everyone attempt this question. A block is coming with 10 meter per second at an angle of 37 with the vertical. It has struck on the surface having coefficient of restitution half. So what angle the velocity vector will make from the horizontal after collision? Question is clear to everyone? Then attempt. I want every one of you to attempt this question. Everyone, please attempt this question. I am giving you one more question for homework. This I will tell you here only. This question I will tell you here only classwork. But another question I am giving you for homework. Have you written down this question? I'm writing the another question and I will tell you the answer of this. Another question I'm writing. A ball having velocity 50 meter per second thrown at an angle of 53 degree. There is a wall of coefficient of restitution half. There is a wall of coefficient of restitution half at a distance of 60 meter. After collision, at what distance the ball will drop on the ground from the wall? It will go like this and it will drop. Yes, maybe here or maybe there somewhere. Okay. Now what is the question? What will be the distance of this ball from the wall after the collision when it will come down? Are you getting this? Everyone, this is the homework for you. This question is homework. What will be the distance of ball from wall after collision when it comes? Is this clear? This is a homework. This is a homework question. This is a homework question and this one is the classwork. I need answer of this from every one of you right now and here. Everyone, I want this answer of this question from every one of you. Yeah, Krishna has given the answer. No need of final velocity. You have to find it out. Abhishek, find it out. What is the final velocity? आपको भी कृष्णा, ईद मुबारक. Abhishek is saying 3. Let's see. See, you can just component it the velocity this 10 meter per second. On this direction it will be 10 cos 37. On this direction it will be 10 sin 37. Okay, what is cos 37? Everyone just tell me what is cos 37? 4 by 5. So 10 into 4 by 5, 8. So velocity in downward direction is 8. Velocity in this direction will be 3 by 5. So it will become 6. So the velocity of ball in horizontal direction is 6 and in vertical direction it is 8. So what will happen? See, this velocity will not change. The collision, during the collision there will be a normal force in upward direction, impulsive force of normal in upward direction. So what will happen? Its velocity will change in upward direction, in vertical direction. There will be no change in velocity in horizontal direction. Okay, so in horizontal direction after collision, and now I am making this direction after collision. After collision in horizontal direction, speed will be 6 only. After collision, the velocity in horizontal direction will be 6 only, it will not change. Yeah, but the speed in vertical direction will change and that will depend on coefficient of restitution. And coefficient of restitution is half. So what is the, let us take the final velocity after collision is Vy. So velocity of separation is Vy upon velocity of approach. Velocity of approach is 8. So Vy is equal to 4. Velocity of separation upon velocity of approach is equal to E. So from here we got that this is 4 and this is 6. So you know you want this angle theta, this is 4 and this one is 6. So you can write tan theta is equal to 4 by 6, 2 by 3, or theta is equal to tan inverse by. Very simple question, very simple question. Is it clear to everyone? Is it clear to everyone? There will be no change in the velocity in horizontal direction. See, all these questions I am giving you so that one concept you can learn from these questions. All that concepts you can revise, all these important concepts. Are you getting my point? That's why I am giving you these questions. So in these questions, what we have read is whenever object is striking from any surface, so the speed is changing only perpendicular to the surface in which normal is there. In the horizontal direction, there is no force, then why the velocity will change? So in the horizontal direction, speed is remaining constant. Initial also 6, after also 6. But in vertical direction, it was initially 8. Now coefficient of restitution is half, so it has become 4. Is it clear? Is it clear to everyone? Abhishek, Krishna, Maruti, Srinivas, Manisha, everyone, is this clear? Just tell me fast. Is this question clear? This question is homework for every one of you, and I am giving you one more very simple question homework. Yashaswini has said yes. Okay, what about others? Everyone, reply fast. Now see, clear. This question is homework. One more question I am giving you homework. 2 kg block coming with 10 meter per second. 1 kg block coming with 5 meter per second. Very simple question. E is half between them. What will be their velocities after collision? Two questions I am giving you homework. After these two questions, your center of mass and this collision will get over. Yeah, oblique collision will left. Only one or two questions I will give you on oblique collision, and then this complete center of mass and collision chapter is over. Is it clear to everyone? Okay, many of you have said clear. Abhishek, Yashwini, Jyoti, Krishna, Srinivas, Siva. Okay. See, these two questions are homework. These two questions are homework. What will be the distance of the ball from wall after collision when it comes to ground? After collision, when the ball is coming to ground, what will be the distance? This is the first question. And the second question, one block is 2 kg, which is moving at 10 meter per second. 1 kg block is moving with 5 meter per second, both towards each other. So after collision, what will be their velocities? Velocities of both the blocks. Okay. So these two questions are the homework for every one of you. And then in the next class, we will start rotational mechanics. Okay, rotational motion. A very important chapter, very important for your EAMCET also, mains also, advance also. For all the three exams, it is very important, very important. Okay. So now just write it down, these two homework, because I will ask you how many of you have done this in the next class. I need answer from every one of you of these two questions in the next class. Then only I will move forward. Is that clear? So till here for today. In the next class, the same timing, Abhishek, the same timing, 8:30 to 10. 8:30 to 10, okay? So now today we are ending this class. Everyone, just practice as much as you can at your home. You have the crash course of each and every chapter. Okay. Okay, thank you, Aditya. Everyone, thank you and bye-bye. Take care.